Okay, so in this lesson, we're going to be looking at solving rational equations. Now, this is really going to be a review of previous lessons, and we're going to look at 3 problems. And those 3 problems, our denominators will involve variable expressions. And then these rational equations, when we solve those, when we go through the process, it's going to lead to linear equations. In a future lesson, though, we're going to look at rational equations that will lead to quadratic. But these are going to involve linear equations at some point. Okay, so let's just kind of remind ourselves on how to solve rational equations. So here are the steps that we perform. So remember, the first thing you have to do when solving a rational equations that involve denominators with variable expressions. All right, so you have to factor all the denominators. And then once you factor the denominators, you're going to multiply both sides of the equation by the least common multiple of all the denominators. And the purpose of that is to eliminate the fractions. And then once you do that, you're going to distribute and combine like terms. Then you're going to isolate the variable. And then this is going to be important. You need to verify that your solution is or are not restricted. All right, so those are the steps. And so one of the other things you want to do in this particular set of examples is this. And we looked at those words in previous lessons, but you also want to identify the equation as an identity, a conditional equation, or an inconsistent equation. Okay? All right, now, so let's remind ourselves about what an identity, a conditional equation, or an inconsistent equation is. So remember, an identity is an equation that is true for all real numbers for which both sides are defined. A conditional equation is an equation that has at least one real number. One solution has at least one solution that's a real number, but it's not an identity. All right, so based on this has at least one solution. All right, but what makes this an identity and this a conditional equation is that an identity is true for all real numbers. You can substitute any real number and it's going to work except where the expression is undefined. A conditional equation has a solution, has at least one solution. An inconsistent equation is an equation that is not true for even one real number. So basically it has no solutions. Now, in most textbooks, they use the word inconsistent. You may see the word contradiction, but for the most part, it's called an inconsistent equation. That's the word we're going to use for the most part. But sometimes you'll see this word, a contradiction. Okay, so let's look at some examples. Oh, and one other thing, well, we'll get to that point when we get to an example like that. Okay, so let's look at number 1. So number 1, we have this rational equation. And so our rational equation looks like this. It's x minus 4 divided by x minus 8, subtract 1, equals 4 divided by x minus 8. All right, now, so we have this rational equation. And notice this is a rational equation. You have rational expressions. So remember, rational expressions defined to be a polynomial divided by a polynomial. So even this is a rational expression because a polynomial can be consisted as a monomial as well. So negative 1 over 1. So these are all rational expressions. In particular, though, remember we're looking at rational expressions where the denominators involve variable expressions. All right, so the first thing we have to do, remember, according to our steps, is we have to factor all denominators. All right, well, if you look at x minus 8, and this is right here is considered 1 over 1, and then x minus 8, you can't factor x minus 8. There's nothing else you can do with this. So finding the least common multiple of the denominators, or the least common denominator, makes things a lot easier for us. So when finding the least common multiple or the least common denominator, remember the whole point is to eliminate the fractions. So if I want to make this a 1, so when you eliminate the fraction, remember you want this to be a factor 1 instead. Well, you have to make sure that your LCD has this factor. So x minus 8 has to be part of my LCD. Now over here, this right here, that denominator is a 1. Well, every expression every expression has a factor of 1 in it. And then the next one is x minus 8, which I already have. Okay, so I found my LCD. Now, when we go through the process, you see that fifth step? So the fifth step is to verify that your solution is not restricted. So what you may want to do next is find the restrictions. Because remember, one of the things we talked about before in many courses is that when you have a fraction, you can't have 0 in the denominator. So once you find your least common multiple, which is a set of factors which consist of the denominators, once you find your least common multiple, you just ask yourself, what makes this denominator 0? And then whatever makes this denominator 0 is my restriction. So you're only, and really you just have to look at the denominators that have variable expressions. This doesn't have a variable expression in the denominator, since that's just -1/1, but these two do, and they're the same. So I'm just going to use this right here. So all we do is we take x minus 8 and I find out where's that 0. So I'll solve this linear equation. And so in this case, x equals 8. So that means that 8 makes this undefined. It makes this expression undefined, makes even this expression undefined. Because look, let's look at this one. What's 8 minus 8? 0. What's 4 divided by 0? Well, that's undefined. Over here as well. 8 minus 4 is 4. 8 minus 8 is 0. 4 divided by 0 is undefined. Okay, so my restriction is that x cannot equal 8. So that's how you would say that. Your restriction is that x cannot equal 8. Okay, so all right, now so now the next step, remember, once you find the LCD, the next step is to multiply both sides by the least common multiple, and the reason for that is to eliminate those fractions. So you want this to be a 1, you want this to be a 1, and you're going to see how that's going to happen. Now, if you recall from previous lessons, see how I have two rational expressions on this side? I'm going to put that in parentheses. So I'm going to go ahead and rewrite this over, just like this, so you can see what I'm doing. And so when you do your work, you want it to look just like this. Leave some space here, and let's put 4 over x minus 8 right here, 4 divided by x minus 8. All right, so I'm going to put this in parentheses, because that consisted of two rational expressions. This is just one, so I'm not going to put that in parentheses. But remember, the next step is to multiply both sides of the equation by the least common multiple. So my least common multiple, my least common denominator is x minus 8. So I'm going to say x minus 8, and I'm going to say x minus 8. Okay? All right, now, so that was the second step. Now the next step is this, distribute and combine like terms. Now what that means is this. So you see I have parentheses here? So I'm going to distribute x minus 8. I'm going to distribute my least common multiple, or you can call it the least common denominator. And so I get x minus 8 times the first rational expression, x minus 4 divided by x minus 8, minus, now be careful here, so this is really 1, so you got to put the 1 there, and then times x minus 8. Now notice, and this was important, notice I put this x minus 8 in parentheses, because both of those terms have to be multiplied by -1, because we're going to have to use the distributive property again. So that's important to have seen. And I'm just going to go ahead and rewrite this over, although you could have reduced at that point. Okay, so all I did, for this step, all I did was just distribute. Now I'm going to reduce. So remember, we distributed. So we use the distributive property, and then we're going to reduce. So remember, when we reduce, notice that these two factors are the same. So x minus 8 divided to x minus 8 is 1. So anything divided by itself is 1. And so I have 1. Now be careful. You see how this is a 1? And this is x minus 4, because x minus 4 divided by 1 is x minus 4. 1 times x minus 4 is x minus 4. Okay? Then I'm going to distribute this. So that's why the parentheses were important, because this becomes -1 times x is a negative x. -1 times a negative 8 is a positive 8. And that's going to equal, now let's reduce this. So the x minus 8's divide out, and you're left with 4. Okay? So now I went from this rational equation to something that looks linear, right? Okay, so let's combine like terms. Now notice what happens when I combine like terms. X minus 4 minus x plus 8 if I combine like terms on this side, the x's cancel out. They add up to be 0, x minus x 0. But a negative 4 and a positive 8 is 4, and that's equal 4. So notice the variables disappeared. And so we talked about this in previous lessons. So when the variable disappears, either so when the variable disappeared, either you're going to get no solution or all real numbers, except where certain things don't occur. So notice, what kind of statement is this? Is this a true statement or a false statement? Is 4 equal to 4? That's a true statement, right? So notice that's a true statement. So what that means is this. So what that means is that my rational equation is the solution be all real numbers, except, now be careful, you see this linear equation right here? That linear equation is true for any real number. So if I plug in 5, watch what happens. 5 minus 4 is 1, right? 1 minus 5 is a negative 4. A negative 4 plus 8 is 4. If I plug in 6, notice what happens. 6 minus 4 is 2. 2 minus 6 is a negative 4. Negative 4 plus 8 is 4. Notice that this right here is always going to be a negative 4, no matter what I substitute in for x. So this right here, the solution to this equation is all real numbers, okay? I can plug in any number for this, for x. That side will always be 4, that side will always be 4. That's what that's saying. But my original equation was a rational equation. So I want to ask you this. Is 8 a solution to this? So here's the question. I want you to think about this. Is 8 a solution to x minus 4 minus x plus 8 equal 4? This equation here. All right, let's check. 8 minus 4 minus 8 plus 8. And the question is that equal to 4? Well, 8 minus 4 is 4. Y'all agree? 4 minus 8 is a negative 4. Negative 4 plus 8 is a positive 4, and it's yes. But, is 8 a solution to this? The answer is no, because that was a restriction. Okay, so that was a restriction. So here's how we say this now. Okay, but 8 is not a solution. 8 is not a solution to the original equation. Okay, because x equal 8 is a restriction. Because x equal 8 is a restriction. So here's how we say the solutions. So the solution, you're going to say it like this. Now there are two ways you can say this. Okay, so listen. So the solution, you can say all real numbers except 8. All right. So that's how you can write it. Some textbooks, though, will say this. They'll write it in set notation. So they'll say the set of x's. So the set of x, notice the brace. I did a bad job with the brace, so notice the brace. So the set of x's such that x is any real number and x cannot equal 8. So that's what that means. So that means the set of all real numbers except 8. Okay, so that's what that means right here. So the set of x's such that x does not equal 8. All right, now here's something else I got to remind you. You see that the directions here identify the equation as an identity, a contradiction, a conditional equation, or an inconsistent. So which one do you think it is? So let's go back to our definitions of those, and here are the definitions. So which one is it? Is that equation right here, is that equation an identity, a conditional equation, or inconsistent? Well, you notice it's not inconsistent, because an inconsistent says no solution. I have some solutions. In fact, I have an infinite number of them. So it's all real numbers except 8. Okay? So it's an identity, right? So an identity is an equation that is true for all real numbers for which both sides are defined. All right, so this is an identity. So this equation, we'll write it down here. So this equation, so the rational equation is an identity. Okay. Now, before I go on, let me just remind you that what is it that we just found. So what that means is this. This equation here, I can substitute any number for x, and this side's going to equal this side. That's what that means, except for 8, because 8 makes it undefined. So watch. So let's check. Let's say, now remember, you can substitute any real number. So any real number works. Decimals, fractions, any rational number, any irrational number works. Any real number, except which one? Except 8. All right, so let's check x equal 10. Let's see why 10 works. So 10 should be a solution. So we go back to the original, and we substitute x equal 10. So here's my original. So 10 minus 4 divided by 10 minus 8, I'm subtracting 1, and I want to see if that's going to equal 4 divided by 10 minus 8. Okay? Well, 10 minus 4 is 6, right? 10 minus 8 is 2. I'm going to subtract 1, and I want to see if that's going to equal to 4 divided by 10 minus 8 is 2. Well, this is 3. Subtract 1, and this is 2. So is 3 minus 1 equal to 2? The answer is yes. All right, and that's going to be true for any real number. So that's going to be true for x equal 10.7, x equal the square root of 8. So all real numbers work except 8. All right, so that's number 1. Okay, so a couple of things you had to remember about solving these. So notice we had to multiply both sides by the LCD. We had to find the LCD. We had to determine the restriction. Go through the process. Make sure you understand what this means. So this when we solve this rational equation, we ended up with a linear equation in which the variables disappeared, but that was a true statement. So what that means is that this linear equation, the solution is all real numbers. Okay? So that's why I asked you, is 8 a solution to this? The answer is yes. But is 8 a solution to this? The answer is no, because 8 makes my denominator 0. So the way we say the answer then is this. We don't say all real numbers, just all real numbers. We say all real numbers except 8. That's the way we say it. So that's how we say it in words, and then that's how you can say it in set notation. Okay? All right, so that was number 1. Let's look at number 2. Number 2, let's suppose we had this in number 2. So let's suppose we had this rational equation, and let's suppose my rational equation is, let's quickly see, the rational equation is all right, so our rational equation is this: 4 divided by x minus 3 equal a negative 2 divided by x plus 7 plus 16 divided by x minus 3 times x plus 7. All right. Okay, so that's our rational expression. Again, notice that my denominators contain variable expressions. And so remember the first step you got to do is factor the denominators. Well, if you look at those denominators, they're already in factored form. So x minus 3 is a binomial. There's nothing, the GCF is 1, so you can't factor that. You cannot factor this. And this is already factored. So it's already listed as a product of factors, and each factor you can't decompose any further. You can't factor any further. Okay? So then the next thing we're going to do now is find the least common multiple, or the least common denominator, however you want to think about this. So the least common multiple, remember, must include every factor of your denominator, because remember the whole point of multiplying both sides by the least common multiple of the least common denominator is to get this factor down here to be a 1. So if that's an x minus 3, then that means I got to multiply this by x minus 3. So that means that x minus 3 has to be a factor. Now I'm going to put that in parentheses, and the reason I'm going to put that in parentheses is because I'm going to really have how many factors in my least common multiple or least common denominator? 2. Whereas in the previous problem, notice I didn't put that in parentheses, although you could have, but I didn't put in parentheses in the previous one because it was just one factor. That's why. but my least common multiple here is going to involve 2 factors, and the other one's x plus 7. So if x minus 3 is in your denominator as a factor, you have to use it. X plus 7 is listed, you have to use it. Now if we go here, x minus 3 is a factor, I already have it. X plus 7 is a factor, I already have it. So there's your least common denominator or least common multiple. All right, now the next thing you want to do before you go on is find the restrictions. So let's find the restrictions. All right, let's talk about the restrictions. So remember, the restrictions is any real number that makes your denominators 0. So any real number that makes each rational expression undefined. Okay? So what makes this denominator 0, x minus 3? So x minus 3 is 0 when x equals 3. So that's one of my restrictions. So x cannot equal 3. Okay? Now if you look at this one, x plus 7, so x plus 7 equals 0, so x equals negative 7. So the other one is that x cannot equal negative 7 as well. So I only have 2 restrictions because in your factor, in your least common multiple, you only have 2 factors that contain variable expressions. So you just find out where's this 0, where's this 0. Okay? So there's your restrictions. All right, now the next thing you're going to do now, remember, is you're going to multiply both sides of this equation by your least common denominator. All right, so I'm going to go ahead and rewrite this, and since I took up a lot of room here, I'm just going to go ahead and put this part down here. So let's just go ahead and do it down here. All right, so I'm going to leave some space here. So I have 4 divided by x minus 3 equal, I'm going to leave some space here, and then I'm just going to rewrite my original problem over. So that was this, negative 2 divided by x plus 7 plus 16 divided by x minus 3 times x plus 7. Okay? All right, so now remember, we got to, since that right here involves 2 rational expressions, put that in parentheses, and then let's go ahead, remember step 2 is to go ahead and multiply both sides by your least common multiple. So my least common denominator, least common multiple, so I'm going to say x minus 3 times x plus 7, just like this, and then x minus 3 times x plus 7, just like this. All right, so I took each side of this equation and I multiplied by the least common denominator or least common multiple. Okay? All right, now you see how I put that in parentheses? So I'm going to use the distributive property on this side. All right, now I'm just going to go ahead right now and just rewrite it. Although if you want to, you can go ahead and reduce at this point. That's fine. But I'm just going to do one thing at a time. So I'm going to distribute here. I'm going to leave this alone for right now. So I get x minus 3 times x plus 7 times 4 divided by x minus 3 equal, and notice that each of these 2 rational expressions will be multiplied by the least common multiple or least common denominator. So it'll be x minus 3 times x plus 7 times the first rational expression plus, and then x minus 3 times x plus 7 times the second rational expression. Okay, now at that point, we're going to reduce. So we distributed, now we're going to reduce. All right, so when I reduce, so the x minus 3's divide out. So remember, the whole purpose of multiplying by the least common multiple is to get this down here to be a 1. So this down here to be a factor 1. So in order to get the factor 1, it's got to reduce with one of these factors up here, and it does. So the x minus 3's divide out. Now be careful. Listen to what I'm saying. So this is now a 1 times x plus 7 times, and then this is 4, because 4 over 1, 4 divided by 1 is 4. So I'm going to rewrite this like this, though. So do y'all agree that this right here, those 3 products, those 3 factors and multiplied becomes 4 times x plus 7? Okay? All right. Equal. Over here, same thing. The x plus 7's divide out. Notice I put 1s in their place. That's important. And then I have x minus 3 times 1 times negative 2. So I'm going to rewrite this as negative 2 times x minus 3. Don't forget parentheses. Parentheses are important. Parentheses are important. And over here, both of these factors divide out. And you have 1 times 1, and that's just 16. So 1 times 1 times 16 is 16, so that's plus 16. Okay, so notice. I want to notice something. I want you to notice something. I went from a rational equation to a linear equation. And so again, I'm going to go through the solving process. So notice this is all the solving process. To solve this linear equation, since I do have parentheses, I'm going to distribute. I'm going to distribute, and so I get 4x plus 28, 4 times 7 is 28, equal negative 2 times x, negative 2x, negative 2 times a negative 3 is a positive 6, and then plus 16. Okay, combining like terms on this side at least, I'm just going to rewrite this over. 4x plus 28 equal negative 2x, 6 and 16 is 22. Okay, all right, now adding 2x to both sides, I'm going to bring all the variables one side, constants to the other, because remember this is linear. So I'm going to add 2x to both sides, just like this. And so I get 6x plus 28 equal, this is 0, 0 plus 22 is 22. Okay, then I'm going to subtract 28 from both sides, just like this. And so I get 6x equal a negative 6, it looks like. Then divide both sides by 6. 6 divided by 6 is 1. 1 times x is x, equal negative 1. Okay? So negative 1 is a solution. So sometimes you call this a proposed solution. So this is a proposed solution. So is this proposed solution a solution to the original equation? That's the question. All right, well, remember when you're going, notice that this is a rational equation. So this process, when I went through the process, all of a sudden I did some stuff here and I ended up with a linear equation. All right, and so now we have a different equation now. So we have a different equation, and this equation to solution is negative 1. But is this proposed solution a solution to the original? All right. So basically the thing is, all you really have to do, if you did this correct, if you did all this process correct, and let me go ahead and make this a little bit smaller so you can see. So if you did all of this process correct, okay, then negative 1 should work unless it is a what? Unless it is a restriction. And so is negative 1 a restriction? No, it's not. It is not a restriction. So negative 1 should be the solution. So the solution, and there's only one here, is x equals negative 1. That's your solution. Okay? So negative 1 works. Now let's check it. Let's check it. Let me go ahead and enlarge this again so I can check this. All right, so let's check negative 1. So remember to check. You always go back to your original equation. The original equation was this rational equation. So I'm going to go ahead and check x equal negative 1, make sure it does work. Now on a test, you're not going to have time on a test. If a test is timed, you're really not going to have time to check. So just be careful. Just make sure your solution process, your algebraic process for solving this rational equation is correct. And then you'll be done. You're good to go to the next problem. All right, but let's go ahead and check it. Let's verify. All right, so where we see the variable x, you substitute negative 1. So I have 4 divided by negative 1 minus 3 equal negative 2 divided by negative 1 plus 7, right? So where we see an x, you substitute negative 1 plus 16 divided by, now be careful here, so that's 2 sets of parentheses you're going to use, 2 sets of factors. So I have negative 1 subtract 3 times negative 1 plus 7. So this is the one we're going to have to be a little bit careful about down here in the denominator. All right, now let's simplify as much as we can. So do you all agree that this is going to be 4 divided by, and the negative 1 and negative 3 is a negative 4. And you want to see that's going to equal this side. So that's negative 2 divided by negative 1 plus 7 is 6, right? Plus, and then that's 16 divided by, now be careful here. So notice what I'm doing. This first factor, that's a negative 1 and negative 3, which is a negative 4. I'm going to write it like this, times, and then this one, negative 1 plus 7, 6. Y'all agree? Okay. Now, here's what we do. So this one, I'm going to reduce this. So y'all agree that is 4 divided by 4 is negative 1. So on the left side, I have negative 1. So hopefully this adds up to be negative 1. So let's see. Let's go ahead and reduce this. So do y'all agree that's negative 1/3? And over here, that's 16 divided by negative 4 times 6 is negative 24. Okay. So let's work on this side. So that's negative 1/3 plus, now if I reduce this, they're both divisible by 8. So that would be a negative, remember a positive divided by negative is a negative. So I'm going to write this as a negative 2, and then 24 divided by 8 is 3. And notice these denominators are the same. And so do y'all see I get negative 1/3 and a negative 2/3 is a negative 3/3, which is a negative 1, which is what this is. So that works. So x equals negative 1 is our solution. All right. Now, here's the thing you got to remember next, though, is this. You got to remember part of the directions was, is this, remember your directions, is identify your equation as identity, a conditional equation, or an inconsistent. Remember, inconsistent, think contradiction also. Inconsistent means no solution. I have a solution. What's the solution? X equals negative 1. Identity means the solution is all real numbers except where it's undefined. So it's not all real numbers. You just have how many solutions? You just have one. So which one is it? It's a conditional equation. So this is a conditional equation. So I'm going to go ahead and write that here. So this rational equation. So this rational equation is a conditional equation. Okay? All right, so that was number 2. All right, let's look at number 3. So number 3, we have this. Okay, so number 3, we have this rational equation, 2x divided by x squared minus 9. And then this is equal to 6 divided by x squared minus 9 minus 2 divided by x plus 3. So that's our rational equation. Now remember, the first thing you have to do when solving a rational equation that have in your denominators variable expressions, and all denominators have variable expressions, is to factor. So let's go ahead and factor these denominators. So I can factor this time because x squared minus 9, remember that's a difference of 2 squares. So that becomes x minus 3 times x plus 3. Now this is the same as this, so that's also x minus 3 times x plus 3. And then x plus 3 I cannot factor. All right, so I factor my denominators. Now I'm going to find the least common multiple. And so the least common multiple of all those denominators, remember every factor you see has to be in the LCM, or the least common denominator, because you want this down here to be a 1. All right, so that means you have to multiply every rational expression by a factor that has these in it. So x minus 3 occurs as a factor, so I have to use it. So x minus 3. The next one I see is x plus 3. I've got to use it, x plus 3. So then I go to the next denominator. One of the factors is x minus 3. I already have it. The next factor is x plus 3. I already have it. So then I go here. X plus 3, I already have it. So my least common denominator, least common multiple, has 2 factors in it. Okay? Now, remember, we are dealing with rational expressions. Rational equations and rational expressions for that matter. There are 3 rational expressions here. So I got to determine where's this rational expression undefined. So let's talk about the restrictions. So let's find the restrictions. So if I look at this, x minus 3, it doesn't matter which one you use. I'm just going to go here. So let's find out where x minus 3 is going to be 0. So x minus 3 is going to be 0 when x equals 3. So my restriction is that x cannot equal 3. Because if x is 3, notice, what's 3 squared? 9. What's 9 minus 9? 0. So, and then 2 times 3 is 6, and what's 6 divided by 0? Well, that's undefined. Okay? So I can't have x to be 3, because that makes this rational expression here undefined. It also makes this undefined. It doesn't make that undefined, okay, because look, what's 3 plus 3? Well, that's 6, so that's okay. But the issue is that it makes these 2 undefined, okay? Let's look at negative, then let's look at the next one. So the next one is x plus 3. So x plus 3 is equal to 0 and x equals negative 3. So there's my other restriction, negative 3. So again, let's check. What's a negative 3 times itself? Well, negative 3. What's negative 3 minus 9? I'm sorry, negative 3 times itself is 9. It's 9, right? And 9 minus 9, 0. Same thing here. Negative 3 plus 3, that's 0 here. So negative 3 makes all of these rational expressions undefined. So those are my 2 restrictions. Okay, now the next step, remember, is to take your rational equation and you're going to multiply both sides by the least common multiple. Now, remember, you need to, when you rewrite the rational equation, make sure you use the factored form. Don't use this. Use the factored form. So in other words, when when I rewrite this, I'm going to use x minus 3 times x plus 3 instead. Okay? Equal, and I'll leave some space because I do have two rational expressions here. So I'm going to leave some space here. I'm going to put that in parentheses. 6 divided by x minus 3 times x plus 3 minus 2 divided by x plus 3. Okay? So now remember, all I did was rewrote this. I put this in parentheses since that was two rational expressions on this side. This side has just one. Okay, so then multiply both sides by the LCD, just like this. X minus 3, x plus 3. Over here, x minus 3, x plus 3. All right? Now, remember, just like before, so you're going to distribute and combine like terms. So I'm going to go ahead and distribute this side right here. I'm going to leave this alone for right now. So x minus 3, x plus 3 times 2x divided by x minus 3, x plus 3. Equal, and then distribute here, x minus 3, x plus 3 times the first rational expression, just like this, minus, and then the least common multiple times the second rational expression, x minus 3, x plus 3 times 2 divided by x plus 3, just like this. Okay? Now we're going to reduce. So notice remember, the whole purpose of multiplying by the LCD, or the least common multiple, is to get these to be 1s down here. And now I do. X minus 3's divide out. X plus 3's divide out. And notice what I have. 1 times 1, and that's 2x, because 2x divided by 1 is 2x. 1 times 1 times 2x is 2x. So that side's easy. Over here, this is nice as well, because notice that the x minus 3's divide out, the x plus 3's divide out, and I have 1 times 6 is 6. Now be careful over here. Subtract. The only thing that reduces is the x plus 3's, just like this. Now be careful. You see how when I'm going to cover that subtraction symbol right here. See I have x minus 3 times 1 times 2. So rewrite it where it's 2 times x minus 3. So it'll be minus 2 times x minus 3. So that's how you needed to have rewritten this. Now you can distribute the negative 2. So notice, I want you to notice something. Notice I went from a rational equation, and what kind of equation is this? Right here. What kind of equation is this? This is linear. All right, so let's solve this linear equation. So I get 2x equals 6, and then if I distribute the negative 2, I get minus 2x. Negative 2 times negative 3 is a positive 6. Okay? Combine like terms, I get 2x equal negative 2x plus 12. You all agree? All right. Adding 2x to both sides, I get 4x equal 12. Divide both sides by 4. My proposed solution is 3. Now I want you to notice something. Let me go ahead and make this a little bit smaller. I want you to notice something. Okay, so this proposed solution, notice I'm using the word proposed. This proposed solution, this right here, is a solution to this linear equation. Check it. What's 2 times 3? 2 times 3 is 6. Okay, so that's side 6. Y'all agree? All right. Now, again, what's a negative 2 times 3? Well, negative 6. So what's 6 minus 6? Is 0. 0 plus 6 is 6. So is 6 equal to 6? Yes. So x equal 3 is a solution to this linear equation. But remember what's happening. Let me go ahead and make this a little bit smaller. Hopefully you can still see it. So this rational equation, now remember that's a rational equation. I went through this process of solving this rational equation, and I ended up with a whole different equation that is linear. I ended up with a linear equation. These are linear equations right here. Ended up with a linear equation. The solution to this linear equation is this. But that's the linear equation. This was a rational equation. Remember, at the end, you must, if I can find those steps real quick, at the end, you must verify that your solution is not restricted. So here's the question. Is x equal 3 one of my restrictions? Yes, it is. It is one of my restrictions. And so because remember, if x equals 3, remember 3 makes this denominator 0, so that's undefined. So that was the only proposed solution. So this, now I'm going to use another word we talked about before. Now listen to this. So you see how x equals 3, through this process I got a solution, a proposed solution of x equals 3. Well, that solution worked here, but it didn't work here, right? Because it made it undefined. So that's called an extraneous solution. An extraneous solution. So let me kind of remind you what an extraneous solution is. Okay, so an extraneous solution is a proposed solution that is not a solution to the original equation. All right, so is this proposed solution a solution to the original equation? No. So I just want to remind you, this is an extraneous, extraneous solution. So this proposed solution is extraneous. So that means that this equation has no solution. So our solution, you're going to say this. Solution, you're going to say no real numbers. Okay, no real numbers. Let me go ahead and expand this. You're going to say no real numbers. And another way you can say it is this. Or you can say, some textbooks will use this, the empty set. So it's the empty set, meaning the same thing as no real numbers. Okay? All right, but no both. No both, because sometimes if it's multiple choice, it may have no real numbers as your solution, or it may have the empty set. So no both ways. All right? So in summary, x equals 3 is a solution to this linear equation, but it's not a solution to this rational equation because there was a restriction, which meant it make my denominator 0 here, here. Okay? It turned out that this was an extraneous solution. Now, later on, we're going to talk about this some more. So when we get into other types of equations, like radical equations, where we have square roots, you're going to end up with extraneous solutions in those as well for some of those problems. Okay, so that was extraneous. So it's no real numbers or the empty set. All right, now let's answer the question. The next part of the question. Is this equation an identity, a conditional equation, or an inconsistent equation? Well, remember, and going back to our definitions, which one is it? It's inconsistent. The inconsistent equation is an equation that is not true for even one real number. So the rational equation is inconsistent. Okay, so the rational equation is inconsistent. Okay? All right, so that's going to take care of this part of the lesson. So remember, all I wanted to do here was just to give you some more examples of 3 rational equations, and in particular, our denominators did involve variable expressions, so you did have to find the LCD, and each of those led to linear equations. Okay, and then you had to know your definitions to get to this point, to understand what this meant. Okay, so that's the end of this lesson.